little background, I'm from academia, so I'm actually targeting students wanting to run Jupyter for my class. So we're going to go over the underlying architecture first. The underlying architecture is that we've got multiple, we start with IPython. Is the kernel is involving in the classic Jupyter case. And IPython actually can have multiple clients and multiple engines, and it has a controller that coordinates them. And so you can have a command line, a GUI, you can have a web server proxying for a browser, whatever. And when we're actually using Jupyter, that kernel, the thing in the way back corner, is typically the IPython component there. But Jupyter itself is language agnostic. It doesn't have to be a Python kernel in there. The kernel does the code evaluation. The server shuffles the data back and forth between the browser. The browser is providing the interface to things. But the files that we're processing are all on the server side of the picture. Where I'm working with students, it's all the same machine. So that does simplify things a tad bit. In general, we want to be able to have it work with the server and the kernel on different machines. Even though they're on the same machine in the case of my students, well, the server is probably on a virtual machine of some sort. Things are not perfectly well integrated between the two sides of things. The complicated part often seems to be getting the data to the server side and, well, accessible to the client side. I never crossed my mind, but I guess in the real world, you sometimes don't want your client side to have access to the data. It's not the world I live in, but yeah, I was just listening to people worrying about that this morning. So the overall picture is the browser is running on the client side. I've got a Docker container that has a web server in it, and the web server talks to a language kernel. And so I have to fire up a Docker container and feed it data that I can also, at least for my students, we have to be able to get to the data also from the client side. We're not covering here the scenario where I have this running on a server, somebody else's machine off-site, or not on the user's local machine where we're trying to, well, I don't care if it's a local machine, but if we want to have one machine that we're serving to lots of different projects and people, there's the Jupyter itself doesn't have any sort of authentication system in Jupyter Notebook. You have to have a Jupyter Hub to provide that kind of thing. That's a separate deal. We're not going there today. The example system that I'm working on, the laptop here, is what I use to teach with. We've got Windows 10 with, well, not Windows 10 Home. There's my students' problem is they all have Windows 10 Home, so they can't run Hyper-V. Good news is I can give them, Microsoft and Ball State have a nice little simple agreement that lets me give the right to my students to use that. But then the Docker runs on my desktop, starts a Linux VM, and typically that just all fires up when my laptop boots. Then when I issue a command to start up a Docker container, the Docker container is actually running on that Linux VM. And I have to use PowerShell to interact with Docker. That's going away soon in the sense that the next version of Docker on one of the next iterations of Windows releases, we'll have a better Windows substance for Linux, which is I'm not using right now, but under the newer version of things, that will integrate better. The basic command line is I'm going to fire up this really ugly long command line inside PowerShell. And the idea is that I'm going to run an image. The image is the last thing that gets that's listed. But the --rm says I'm going to fire up this new image and not make changes to it. I don't want the changes to persist because then the image gets messed up every time I have to do something. Because I make mistakes. And then I have to specify the port mapping between the container and the host on which the container is running, in my case, localhost. And then a mapping between the local file system, $home/work is a directory on my machine, on localhost, and the name inside the file system of the container. And I'm basing my work on stuff that the Jupyter.org people put out, and they have their username in their Docker containers as Joyvan, and I think I misspelled that. It's Jovian. That keeps on being. I have dyslexia issues. I keep on getting the two things swapped there. So we start up a container, start a browser, copy a URL around, and then type an ugly mess in the browser. I was told to be careful with live demos. We'll give a quick try because I think I've got this set up. And all I have to do is share my screen with you. Instead of share the X separate screen, let me give this a whirl. So in PowerShell, I fire up the command that we showed earlier. Type it, and it fires up the container, and the container starts running and doing its thing. And then on the browser side, I had to, well, localhost, yeah, all that, this really long token string. That's how the authentication is managed. When the container starts up, it fires up a unique token, and I have to authenticate against my own Docker container that I'm running locally. Oh well, if you're actually running in a multi-user environment, that can be handy, I suppose. It just seems a little awkward right now, but and then the thing that's interesting from my point of view is that typically when you fire up Jupyter and start up a new notebook, you get your choice of what kind of notebook as Python 3 or Python 2, if you're lucky. You have that much choice, and I have a much more wide variety of choices here because that's what I teach. I teach programming languages. So I want to, in the Jupyter environment, use that to teach a wider variety of programming languages. Point is, in order to make that happen, I had to roll my own because asking students to put this stuff together, it would never work. I have all sorts of fun when I tell them, here's the detailed instructions, just download this and install it on your machine, and let's use that. Half of them will still decide to download something else because they couldn't follow the directions, and then the other half will decide they knew better, and they have a better way to install the piece of software. And then they install, I found I was teaching Swift, and yeah, they decided to download the Apple version of Swift instead of the Linux version of Swift, and it didn't. Everything that worked on their machine didn't work on my machine, which means they all failed their homework and they were upset. Okay, so the process is a bit awkward to get things going, but once you got things going, things work reasonably smooth until, well, okay, I was just a few minutes ago firing it up, and then it didn't work quite the way I wanted to. I shut it down by hitting Control-C in the PowerShell environment, and the container is still running. So it didn't, when I tried to then fire up another instance, they were both trying to listen on the same ports. That's no good. So I had to kill off one container before I could start the next container. Anyway, and so there was some maintenance of the images. I had to list the container, kill the container that was running in the back, that was still running. The same sort of issues when you're developing lots of Docker images. You end up with Docker images that you would like to get rid of, and you have to. So you have to learn how to maintain the Docker system a little bit. To actually get the Docker image going, I use a command that looks something like this. I've thrown into it. Well, this is what gets run. I have a script that makes so I don't have to type all that, and it does things like insert the current date. So the tag of the image that I'm building is always the current date, and I have a username, and because eventually I'm going to stick the image into a Docker registry, and I have a username on the Docker registry. I use the public Docker registry run by Docker. Toss it there, and then my students can download it, and it's silly. We throw gigabytes back and forth, and it all goes ridiculously fast. So we're not going to talk right now about how to build the image. We'll get there. But then once I have an image built locally, I push it off to the registry, and then have my students pull it back down. Actually, I push it back. I don't actually build the images on this machine. I have a separate machine that I do that, so that I make sure I'm replicating the student experience, my user's experience. That they have to. I see what they're going to see instead of seeing something different. Again, a lot of the point of this is if we're running things inside a container and we're all pulling from that same container and running things in that same environment, I'm never going to get it worked on my machine and it didn't work on yours. And sometimes it's me saying that it didn't work on yours, and sometimes it's a student saying, on the other hand, something worked for them and didn't work for me. We want to all be using the same exact set of stuff, and the only way I know to get the exact same set of stuff is to package it in something like a Docker container, or a virtual machine, or whatever. I've played with virtual machines in the past, and instead of Docker containers. But sort of to give you the comparison about how virtual machines versus Docker containers work, if we're not familiar with that sort of thing, virtual machines come in two flavors, a type 2 and a type 1. So I've got a type 2, we have the operating system kernel runs on the hardware, and a hypervisor runs on the kernel, and guest OS is run on top of the hypervisor. So my software application is 1, 2, 3, 4 layers away from the hardware. Examples of that sort of thing, Oracle VirtualBox, VMware, Parallels on a Mac, those are all fairly common. I used to use VirtualBox. Alternatively, you can use a hypervisor, in which case your application is 1, 2, 3 layers because now the hypervisor is on top of the hardware instead of an operating system kernel, and your guest OSs sit directly on top of the hypervisor instead. Examples of that sort of thing, Linux, KVM, Windows, Hyper-V does get things one notch closer to the hardware than we were with the Type 2 hypervisor. Containers are, well, now I'm one notch closer yet to the hardware. And my application software is going to run in a namespace inside my operating system kernel, and I have another namespace, and a container is simply not the default namespace for everything. But my application runs on top of the kernel the same. Well, if I'm running in here I'm sort of it's a hybrid environment because I'm running Docker on top of Hyper-V, and it's not quite this pretty. But on my development machine, it's pure Linux, and this is exactly what it looks like on the development side. And so the container's running in a separate namespace, but it's on the same kernel as everything else. Nice close to the hardware. There's not a lot of performance getting in the way, performance issues. So yeah, here's the picture of reality with what I'm doing on this machine. Is I've got I do have an OS kernel sitting that is fired up by Docker, which sits on top of Hyper-V, and well, the picture shows, the point of the picture is really here showing that once I have Hyper-V running, once I've installed Hyper-V on my machine, everything is running at the same layer. My applications in my container are no further away from the hardware than anything else I'm doing. Okay. If you really don't like running things inside Docker, you could just run things straight on top of Ubuntu or whatever installation on top of Hyper-V. That works fine too. I could just as easily, I suppose, hand my students a Hyper-V image as a Docker image. Well, it's not quite as easy. That's why I'm doing it this way. It's not. Then they have to also figure out how to use Ubuntu, and I teach something else. It's a good thing to learn, but it's not the topic of the course. When I'm building these images to share with people, I start with images that are built by Jupyter.org and put on GitHub. And again, the approach here is to make things, avoid this whole, it worked on my machine and doesn't work somewhere else example. So we start with images provided at this GitHub repository. And what we're building is an image. Well, an image ends up being essentially a virtual file system. And it's, it's a set, they're called a set of layers. A layer is really just a root of a directory, and an image looks in the top layer, and if it finds the file there, great. If it doesn't find the file, it looks in the next layer further down. If it doesn't find it there, it looks in the next further layer down on ad infinitum. And typically we're talking about things that have 20, 30 layers by the time we're done building something interesting. Again, the Jupyter project builds things on top of an Ubuntu image and uses the Anaconda distribution of, well, not just Python, but there's lots of fun stuff that they provide. And what Anaconda then provides is package management of binaries as opposed to source. So we don't have to compile everything from scratch. There's, again, but we're getting binaries from somebody we presumably trust. And so in a Docker file, when we're building this is the language that we're using. We specify an image, and then every time we run a command, something like run, it's going to build another layer in the image. And it's assuming that every time we run things, it's going to produce the exact same result as if we ran that same command on top of the same prior layer. So if I edit my Docker file and I rebuild, it's going to look at what it built last time and say, well, you ran this exact command. You didn't edit this line. So it will just use what it built last time and not rebuild a new layer. It essentially caches the results. So if it'll go up to the line that I made the change, and then start building something new and different. Another set of layers on top of existing layers. And in the end, it does something like expose some entry point, and teeny is not teeny as in tiny, it's init spelled backwards. That's in a Unix system, init is the first thing the kernel will run. Once the kernel gets done booting, it starts things up by running init, which runs all the stuff in userland. This sets things up so that a particular shell script runs. And then the last thing I do is, well, I copy something in from the directory that the Docker file lives in into my image that I'm building. And as soon as I use a copy command, it invalidates my cache. So I do that last. If I did that earlier, it would have invalidated the cache, because it assumes that the stuff inside the container is not changing, but it assumes everything outside the container is subject to change. So if I'm copying something from the outside in, it invalidates the caching property. And then the last thing this happens to be the Docker file from Jupyter's minimal notebook or base notebook. I guess this is base notebook. And then sets the user back to not root, because I'm not crazy with security. I still don't run things with root privileges inside containers. Some people are a little less cautious. I'm a little more paranoid. But the basic pattern is we're going to start with some base image, use the package manager to install some package, download some stuff perhaps, and then run things like conda and pip to pull things, well, conda pulling from Anaconda, pip things to compile from source things that are not available in Anaconda. So things that are from the Python libraries are a little larger set than the things that are available from Anaconda. So we install some packages, and then we run a few things, and that builds the image, and then we're ready to go. There's a hierarchy that Docker puts together. That Jupyter.org puts together. It has this Docker Stacks project in its GitHub account. And so they start building things on top of an Ubuntu distribution. They have a base notebook which installs Jupyter itself, but not much in the way of just the absolute bare bones number of packages to get Jupyter off the ground. Minimal is, as in minimally useful. You can do some interesting things with minimal notebook. And then I build things on top of minimal notebook. I've been thinking maybe it should go one notch or two notches further down on the hierarchy and build things on top of that, because every time Jupyter.org fixes something, it tends to break something I've done. And if I use, presumably when they fix things, they'll have fixed it in the down level versions as well. And if I build on something a little higher level, maybe it'll break less often. That's the basic idea. Then hand that off to my students and tell them to do stuff. And I get mixed results. But the mixed results I'm getting are not of how do I use this tool. That was always the fun thing before. I give them some IDE for some set of languages. They would always have questions about how to use the tool, how to use the IDE. I want to answer questions about how to use the language, not the tool, not the IDE. With Jupyter, I'm not getting those questions. That makes me happy. Questions?
Yeah, we have questions. Actually, there's a question up on the screen if you want to. If you want to read that off.
So what is Jupyter great at doing? Give some examples on why you would want this tool and setup. Okay, so Jupyter, let's give a quick look at what Jupyter actually does then. That was what we had. I left it running in the background there somewhere. I just got to go. So once what Jupyter does for us is it mixes code in Markdown with a chunk of code in whatever language we're working here. This one happens to be in Python. Here I'm trying to, I'm needing to, and so the whole thing is visible in as an HTML page, and it saves the state of things. So I haven't actually run any code yet. I just fired it up. No code has run, but remembers what I was looking at, what it was displaying last time I ran it. So when I ran the notebook, I ran each of these chunks of code. It produced output, and it's saving not just the code, but the output. So there's three kinds of things I'm looking at. I'm looking at things in Markdown, which are essentially documentation, chunk of code that got run, and then output. And in this particular case, I'm looking at rendering a graph. And again, the point is that we can render things, we can display things that are more interesting than just plain text. No one wants to see things running in a dumb terminal anymore. So I have things, the default system is able to display, HTML and SVG and stuff like that. So the graph I using code that generates graphs in SVG format, and then we just display the underlying SVG. I don't have to look at the underlying. I don't have to look at the ugly stuff. But that set of that's a nice way to present to somebody where they can see exactly, without having to run my code, exactly what my output was. But then if they have Jupyter, I can have this displayed to them in a non-executable format. there's a notebook browser that just lets them view things, or they can fiddle with it and run it. We're going to say, what if you had done this instead of that, and then push the button and say, well, what if I had looked at this as HTML instead, and okay, let's rerun that, and okay, HTML, whatever. You can play the what if scenarios, see what's going to happen, and not have to rerun everything from scratch. Which, when you're loading in piles of data, you don't want to have to rerun the program from scratch every time.
Yeah, I have a couple of comments. My name is Gregor. I'm from IU.
Mm-hmm.
I do extensive education. And the first comment...
We're not going to fight here, are we?
No. The first, I support any university in the entire universe. The first comment I actually have is from our experience, we have the same experience that you have, that the students cannot sometimes type in even the documented command that you put into your manual. For this reason, we have actually written a tool that's called CMD5, which is an extension to the CMD tool in Python that uses doc-ops, which is an IEEE format specification, so that you can instantiate your Docker containers with a command such as start Jupyter.
Sure.
And I would think that would be beneficial. The second comment is I'm actually part of the no one generation. I actually love command lines because it's easy. And the thing that we found is when we teach our students Jupyter notebooks, they can no longer do object-oriented programming. So any program that I have to do, the students are coming from the undergraduate projects or departments, and I ask them to write actually an object-oriented programming code. They no longer know how to actually use a Python IDE because that's not anymore taught, because we are using all these Jupyter notebooks, and they don't know any object-oriented programming anymore. So they can only develop programs that are 300 lines of code using functions. So I would caution the overuse of Jupyter in the educational frame.
I agree.
And and then the other thing is we solved in this year's class, we actually did something interesting, because we just went to Google and used Google Colab for exactly what you just display, and removed the deployment issue that we see on students that use, for example, Windows Home Edition. So they can use Google Colab for many of the activities. And when it's getting more complicated, we then advise them to use maybe Jupyter on their notebook.
Cool. Yeah, we're on the same page. I wouldn't be doing this in an introductory level course. This is done in a programming language course where I'm trying to show them 8 different languages, and we're never going to get in that course to writing big programs. All we're showing them is a little bit of this and a little bit of that, and we never get to big anything in that kind of a course. If you're going to do things where you're doing non-trivial programming, you want a real live IDE. Yep.
So I've got a question. Do you feel like there's an advantage to having them run Docker and Jupyter notebooks locally on their own computer versus using a cloud service like Python Anywhere or the Google Colab, or Microsoft has Microsoft Notebooks now?
When we started doing this, I wasn't aware of how many were out there. And the ones that I was seeing that were out there, I was having problems getting them to share file system with me. It was getting awkward to move data back and forth. Again, they had a very limited number of Google Colab. I get frustrated with, because it has a very limited number of packages. At least, maybe not limited, it has a lot of them, but not the ones I want.
Right.
There are other ones where you can build, essentially hand them a Docker container, a Docker file and have them build on their side and then run on their side, and that would certainly be doable.
Yeah, Python
as
Anywhere gives
well.
you kind of a standard set. The Microsoft notebooks, you can put a requirements file in there, and it'll just install into the notebook the things you need.
Again, if you're running, yeah, this is a Python conference, so all you care about is Python.
Oh, right. So, of course.
But yes, that would be good for you. Not good for me, because I'm trying to do 6 other languages, or 7 other languages, total of 8, right? Python is one of them, and my students are always shocked that you can actually do object-oriented programming in Python, because they were taught Python in the freshmen, but not object-oriented.